Hello everyone. Welcome to this session on native app development using Java. I'm Varshath Nikhila, Assistant Professor in the Department of Information Technology at Vailtech Multitech, Dr. Rangarajan, Dr. Sagandala Engineering College. The second, in this video, I will walk you through the fundamentals, benefits, tools, and even some basics of frameworks used in native app development. So, let us begin with the fundamental comparison of native apps versus web apps. This is often the first decision made during an app development project, and it influences performances, cost, user experience, and even scalability. Here, native apps are built for a specific platform, says Android or iOS, using the platform's own tools and languages. For example, Java or Kotlin for Android and Shift or Objective C for iOS. These apps are installed directly onto the devices and have full access to hardware features like camera, GPS, notification, and sensor. That means better performance and smoother experiences. On other hand, the web apps. Web app is in contrast are accessed through a browser and built using web technologies like HTML, CSS, and JavaScript. While they are easier to develop and maintain due to a single code base, they are lack because they are lack the deep integration with device features that native apps offer. So, if your app needs high responsiveness, offline capability, or deep device integration, native is the way to go. Then, the benefits of native app. Now, let's explore the specific benefits of native app. These benefits explain why companies like Instagram, WhatsApp, and Uber continue to use native app development for their core mobile application. Performance optimization, enhanced user experience, access to device features, offline functionality, and better security. Here, in a performance optimization, since native apps are compiled specifically for the device, they load faster and respond more efficiently than hybrid or web apps. On the other hand, the enhanced user experience, it means they follow platform design standard like material design on Android or human interface guidelines on iOS. This makes the app feels familiar and intuitive to users. Next one, the access to device features. If we see up to the device features means native apps can directly utilize device functionalities like GPS, camera, Bluetooth, uh, and push notifications like that. Then offline functionality. Offline functionality, the many native apps continue to work without an internet connection, which is very crucial in areas with low or inconsistent connectivity. Then better security. Better security means the native development allow implementation of platform specific encryption, secure storage, and biometric authentication like face ID or fingerprint scanning, like that only. Then, what are the scenarios to create two native apps? Then think. So, when should you choose native development over alternatives? If we have other alternatives like web hybrid app, web app, then why we choose native over others? First one, high performance requirements. Think of 3D games, video editing apps, or AR based experience. Native apps handle real time rendering and graphics far better. Okay. Then, complex user interfaces. Complex user interfaces means, in the sense, if your app requires a custom animation or a non-standard navigation patterns, native frameworks give you the control you need. It give the total control as you need. Then, long-term project viability. In the sense, app with a long roadmap, frequent updates, or enterprise level use cases benefits from the maintainability and scaling potential of native code. Then other one, the targeting specific audience. For example, if 90% of your as users are in iOS, why not build an optimized and iOS experience using Shift? Um, I think you can understand. And next one, the tight device integration. In tight device integration, apps that are rely heavily on location tracking, camera APIs, health data, or sensor input will always perform the best when developed natively only. And we are going to the next topic. What are the tools for creating native apps? So let's take a look at major tools developers use for native app development. So, first one, Android Studio. Android Studio is the Google official IDE for Android. It supports Java and Kotlin. With some comes with a built-in emulator, debugger, layout, and performance profilers. Then Xcode. The Xcode is the go-to IDE for iOS and Mac OS apps. It packaged with the powerful interface builder, testing tools, and supports both Shift and Objective-C. Then Flutter. Flutter, React Native. If we take a Flutter means a Google UI toolkit for building native app like from a single dart code base. It's known for its hot reload feature. It offers a near native performance. It offers a near native performance. Then React Native. If we take a look at React Native, a JavaScript based framework that allows code reuse between platforms while still rendering UI using native components. And Eclipse. If though Eclipse is a older version, but it's still used for a certain Java based Android projects and offer great debugging and plugin support. So these are the tools for creating a native apps. The tools will be Android Studio for Android, Xcode for iOS, and Eclipse for open source for the Java development framework. That only. And next topic, the disadvantages of native apps. So there are lot of advantages in native apps, but there are some downsides too. Here, the native apps comes with some trades off, high development costs. So you think you often need to maintain separate teams for Android and iOS unless using a shared language platform like Kotlin multi-platform. And then app store dependency. Every update must go through Apple or a Google review processes, which may introduce delay or rejections. Maintenance challenges. If you take on the maintenance challenges means, then changes to UI or logic must be implemented separately for both platforms like Android or iOS, like that. Then longer development cycles. Longer development cycles means the testing, deployment, and debugging take more time when you are managing two code bases. Because iOS, if you take iOS means it is a separate code base, and if you take Android means it's very completely different code bases. So it took a longer development cycles. And then platform limitations. You are tied to guidelines and limitation imposed by Android or iOS, such as background activity restriction or UI standards, like that only. So the major disadvantages of native apps will be high development costs, maintenance challenges, time consuming, platform specific, like that only. Other one, the popular native frameworks. The what are the popular native development frameworks? So let us look some frameworks and SDKs that dominate the native development spaces. Okay, so here, Android SDK includes the libraries API and tools needed to build to Android apps. iOS SDK. Here, the iOS SDK contains all the resources, frameworks, and service provided by iOS. For iOS SDK contains all the resources, frameworks, and service provided by Apple. React Native. React Native allows developers to use JavaScript and to React to build app that run natively on both Android and iOS. Then then the next framework, Flutter. The Flutter let you build visually attractive apps from a single code base using the Dart language. Then if we took Xamarin, like the framework, Microsoft back framework that allows cross-platform development in C Sharp, and it provides a near native performance with coding sharing. So here are some popular native development frameworks, like for Android, Android SDK, and iOS for iOS SDK, like that only. And next topic, Java and Kotlin for Android. Here, Java was the original language for Android development. It is object oriented, and it's very popularly known for Android development only, and it's object oriented, stable, and has a vast documentation and community support. But now, Kotlin is Google's preferred languages for Android, because Kotlin simplifies coding by offering modern features like null safety, extension functions, lambda expressions, smart casting, like that only. So the migration from Java to Kotlin is smooth, since Kotlin is fully interoperable with Java. Developers often write new code in Kotlin while maintaining legacy code in Java. So both languages tap into the full potential of Android APIs. Then in other one, shift and objective for iOS development. Uh, on the development side, traditionally relied on for iOS, it traditionally relied on the Objective C, a C-based language that's powerful that but verbose. Then it came Shift released in 2014. Shift focuses on safety, speed, and readability. So the key features included the Shift has a type inference, optional and safe unwrapping, strong error handling, lightweight syntax. So another big plus is Shift is interoperability with Objective C, meaning you have to gradually modernize legacy code bases. So Shift and Objective C is majorly used for the Android, sorry, iOS development. Then the basics of React Native. So what is the React Native? React Native deserves a special mention because it allows developers to build truly native feeling apps using JavaScript and React. So here the concepts include like JX, JavaScript syntax extensions that allows HTML like UA declarations, then core components like view, text, image, like one. Then prop and state for and data management and UA rendering. It offers near native performance by rendering UI components through native API, and has an enormous development community supporting it. So the basics of native React Native is it is also a open source framework for building mobile apps with JavaScript and React. Then native components in React. So here in React Native, native components are the backbone. The native components are backbone. These are pre-built modules that are talked directly to the OS level APIs. For example, if you when you use camera roll, geolocation, or push notification iOS, React Native bridges you with the JavaScript code with the phone's actual hardware. You can even write custom native modules in Java for Android and Shift for iOS and link them both with your React code base for best of both worlds. And another JX. JSX is the JSX is stands for JavaScript XML. It looks like HTML, but it used inside JavaScript code. Then it's not recorded in React, but it makes your code more readable and intuitive. You can embed JavaScript expression using curly bracket inside JavaScript code. And then it supports conditional rendering, loops, and even function calls. JX must be compiled by using Babel into standard JavaScript before the browser or engine can interrupt it. So the JX is the syntax extensions of JavaScript that allows for HTML-like code in JavaScript files. And also benefits of using JS is readably and intuitively links UI elements with logic like that. Next, state in React Native. So, what is state? State refers to a component's internal data like current user input, screen, mode, or loaded API response. In functional components, we manage state using the state of hook. So, then basically hooks like use state simplify state management in functional components. When state changes, the component automatically re-renders and keeping the UI in sync with the data. The best practices like keeping data local where possible, using state management tools like Redux or Context or API for large apps, avoiding unnecessary re-renders by optimizing components like one dot only, and understanding props in React Native. The advantages, sorry, the props for properties used to pass data from parent to child components. They make your components reusable and customizable. You can pass static values or even functions as props. Use default props to assign fallback values and prop types to validate expected types. Using props effectively helps reduce code deduplication and keeps your component modular and clean. So, let's wrap up. We have seen how native app development, especially with Java, offers performance, integration, and superior UX. We compared it with web apps, and also we explored tools like Android Studio, Xcode, like that, and touched on modern frameworks like Flutter, Xamarin, and React Native. As the mobile development evolves learning, these foundations ensures you are ready for trends like AI enhanced apps, then wearable integration and platform convergence. So thanks, thanks for watching. If Thanks for watching. Thank you.